All right, people, let's talk about this trough problem. So this one's a little bit tough, especially if you don't remember certain like formulas and things of that sort when you're dealing with shapes, like triangles and area and all that stuff. So let's go through this here. We're given a trough here where it's an equilateral triangle of the, let's call it the base of this or whatever here. And all of the sides are equal to x, whereas the height or length of the trough is 12 feet. So we're writing an equation for the height of the equilateral triangle. So I'm going to zoom in here real quick. We're looking for this length right here. We know that this is x and x here. So first of all, I'm really just breaking this down into a triangle where if I just take this half here, I know this is the halfway mark between the two sides. So that's 1/2 x. This is x here, and I'm looking for the height here. Couple of ways to do this. So just as a reminder, if you know your 30, 60, 90 triangles, because this is an equilateral, I know this is 60 degrees. This was cut in half. So this is going to be 30 degrees, and then this is 90. So we could use what we know about special triangles. If that didn't come up, that's fine. You can still just solve it using Pythagorean theorem. So you could do, 1/2 x squared plus whatever the height is squared equals x squared, and then solve for that. And if you do, I'll do it here so that you can see kind of what happens. I distribute that squared, and then I got plus h squared equals x squared. Now I subtract all of this to get the height is equal to x squared minus 1/4 x squared. Then I take the square root of both sides, and I got height equals, oh, my bad, I should probably have combined like terms here first. Since these are both x squared here, that's really, x squared minus 1/4 x squared, so it should be 3/4 x squared. And now I'm taking the square root of that, so that's my fault. And we get the height is equal to the square root of 3 times x over 2, because the square root of 4 is 2. And again, we should have known that already because we know that with 30, 60, 90 triangles, that's kind of like our specialty, right? Because the smallest side is 1/2 of the longest side, and the middle side is √3 over 2 of x. So our height, √3 x over 2. The second question says write an equation for the volume. So really quickly on volume, a reminder here is that we need to find the area of the base of our figure and then multiply it by the height. So when I'm looking at this, if I look back at my triangle, if I'm looking for the area of this, area of a triangle is 1/2 base times height. My base here, since it's an equilateral triangle and we're given it's x, then my height here I just did here. So I'm going to say that the volume, actually we'll just do the area first, sorry. We'll do that the area is equal to 1/2 of x times √3 x over 2. And so when we're dealing with this, multiply across here. So we got √3 x squared over 4. And that's our area of that triangle. So what that means is that we then need to multiply that by the height, or I guess in this case we'll call it the length. So we're going to multiply that by 12, and that just cancels. I'll rewrite it as like 3x squared √3 for my volume. And again, you can write this a whole number of different ways, but we'll call it 3x squared √3. So for C, it says, if the trough can hold 200 cubic feet of water, how deep is it? So what that means is that we're given the volume. So the volume is 200. Now I'm going to rewrite this equation, 200 equals 3x squared √3, and I'm going to solve that for x. And when I solve that for x, I divide by 3 root 3. So 200 divided by 3 root 3 is x squared. I take the square root of both of that. In this case, I could start simplifying and stuff, but since I see this root inside of a root, I'm probably just going to plug this into a calculator. So once I plug that into a calculator, I get my x value here of, I think 5.4. I maybe made a mistake on that. I'm sure someone will mention that in the comments, but that's my x value, and I'm looking for how deep it is. So I got to plug that back into here. And so when I'm dealing with that, I plug it in, I multiply it by root 3 over 2, and I guess I will actually plug this into a calculator so I can double check my work here. So I'm first going to do 200 divided by 3 root 3. And I'm going to take the square root of that. Oh, that's 6.2? Sorry, I guess this one should have been 6.2. Sorry about not checking my answers before this. Kind of a long video anyways. And then I'm going to multiply that one by root 3. And then divide that by 2. That's where I got my number from. So then when I plug that back in, my height, or I guess depth, is going to be about 5.4. So again, I kind of rounded because I'm plugging numbers in and getting lots of decimals, but my depth there should be about 5.4. So a bit of a doozy of a problem, lots of stuff to know. This is not something that I'm necessarily going to ask a lot of, but it uses a lot of techniques that we're going to need down the line. So it's a good practice problem.